In the previous classes, you have seen several examples of the numbers in which the literal numbers were used. For example, 4a root 3 by 4 a square, a plus b plus c, 4 by 3 p r cube, x square plus 2x plus 3, or you can say x plus 3, and root x by y. I'm taking more examples, m minus 9 and 2p plus q. Okay, these are some of the examples that we are taking, so zooming it in. So what you can say, all these are the algebraic expressions. In these algebraic expressions, some have only one term, some have two terms, while the other may have three or more terms. For example, 4a root 3 by 4 a square, and so on. These all are the expressions having only one term. Okay, so now when we go to the other examples like x plus 3, m minus 9, 2p plus q, and etc. are the algebraic expressions having two terms. In m minus 9, m and minus 9 are the two terms, and 2p plus q, 2p and q are the two terms. Similarly, we can see a plus b plus c, x square plus 3x plus x plus 3, and are the algebraic expressions having three terms. Okay, in a plus b plus c, a is the first term, b is the second term, and c is the third term. In the second example, x square is the first, 2x is the second, and 3 is the third term. So can you think of why these have two or the three terms while the several expressions have longer contain only one term? Okay, the term of the expressions is a number or a literal number or the product of one or two more numbers and the literal numbers. Understood? The expression can be long with many numbers and the literal numbers multiplied to each other. Any expressions is made up of only one or more than one term. Clear? The terms of the expressions are based upon the plus or the minus and not on multiplication or division sign. Make it clear. Okay, always remember that. Okay, now look at some more examples. Let's see. Let me rub this first. Okay, now suppose we take the expression as 2p plus p and x plus 3 whole square and x minus y whole square, suppose. Okay, so when we look, how many terms will these terms have actually? Will these expressions have? So by just looking at all these three expressions, it may seem like one of these has the two terms in these terms as separated by plus or minus, but it is not like that. We can replace 2p by 3p. Okay, 2p plus p added together, it becomes 3p. Okay, so now when we look at x plus 3 whole square, it can be written as x square plus 6x plus 9. How it becomes? Because a plus b whole square is equals to what? A square plus 2ab plus b square. So using the identity, we get x square plus 6x plus 9. Okay, again moving further, using the identity a minus b whole square. Okay, so what is a minus b whole square? A square minus 2ab plus b square. So by that, what we will get? X square minus 2xy plus y square. Okay, uh, so now, so you saw that when we simplify the expressions, we find the number of the terms can be different from what appears to be before simplification. So therefore, we say that if it is possible to write an expression in simplified form, then we must count its term only after writing its simplified form. Now let's take some of the examples in which these are the polynomials while these are not the polynomials. Now when I say all these expressions are the polynomials, so can you see any differences or the common thing in this? Okay, so the common thing is all the powers, that is the exponents of each of the variable over here in all these expressions are, what you can see is the whole number. Like over here there is a power is exponent of the variable x is 2. Over here on the, when you say x to the power 1 and y to the power 1, so therefore that here it is also a whole number. X to the power 3 is also whole number, x square is also whole number, x is also having a power of 1, so it is also a whole number. Similarly in this expression also, but these expressions are not the polynomials. Why? Because it is over here, so look at the variable x square, though it is a whole number, but y is having the power of, it is y is in the denominator, so when we transfer it, it becomes x to the power minus 1. Okay, so therefore we cannot say that it is a polynomial. Similarly, when we go for the root of x means what? X to the power minus 1, or x to the power 1 by 2, so it is a fractional number. Okay, but it is not a whole number. Though in this expression, though the x is the first term 5x square is having the power as 2, but in the second term, look at the second term, it is minus 2, which is negative, therefore it is also not a polynomial. Similarly in this expression, it becomes x to the power minus 1, which is again negative. Okay, y is also having the negative power, therefore it is also not a polynomial. But in this case, all are the exponents of all the variables are the polynomials. So these type of the expressions are known as polynomials. So you have learned about addition, subtraction and the multiplication of the polynomial in class 9th. So let us consider the operation of the addition, subtraction and multiplication once again. Okay, suppose if I ask you to add x plus 3 and x plus 4, so how will you do this? As you know, though, first of all, because you are being asked to add the numbers, so what we will do, we will put a plus sign in between the two expressions. Okay, as the question is to be asked, and then now open the bracket, so what it becomes, x plus 3 plus x plus 4. Now in this you can see that x and x is the like terms. Okay, they are like, therefore we will rearrange them first, x, group them. Okay, x plus 3 plus 4. Okay, so x plus x is what? 2x, while 3 plus 4 is 7. Okay, understood? That you are already familiar with this, but then also you have to go through it once. Okay, practice it, then you will get. Now let's do the subtraction. Suppose the question is subtract x square plus x minus 2 from the polynomial 2x square plus 3x plus 5. Okay, so how will you do? Because it is asked, it is from a second term, second expression is what? 2x square plus 3x plus 5. So we will write it first. 2x square plus 3x plus 5 minus x square plus x minus 2. Okay, now open the bracket. 2x square plus 3x plus 5. When we open the bracket, it becomes what? Minus into x square is minus x square. Okay, next comes plus into minus becomes minus x, minus into minus becomes plus, so it is plus 2. Okay, now identify the like terms. So which are the like terms over here? 2x square minus x square plus 3x minus x, and the constant terms, that is plus 5 plus 2. Okay, we grouped them together. Now it becomes easy for the subtraction. Okay, 2x square minus x is what? X square plus 3x minus x is 2x, and 5 plus 2 gives you 7. Okay, easy. So we did this also, subtraction also. Okay, now moving further, you have also seen multiplication in 9th. So now suppose the question is to multiply x plus 5 to x minus 7. Suppose the question is to multiply x plus 5 to x minus 7. So how will we do now? We will see this also. X plus 5 multiplied by x plus 7. Okay, so first term we will distribute, we will use the distributive property in this. First term of the first expression multiplied by the second expression. Okay, again second term of the first expression multiplied by the second expression. This is how we have distributed it. Okay, we already studied the distributed property in your previous class, that a plus b into b plus into c plus d becomes what? A into c plus d, a plus b into c plus d, right? So when we open now, so open the bracket, x into x becomes what? This x into x becomes x square. Similarly, this plus is over there, so x into 7 becomes what? 7x plus 5 into x becomes 5x plus 5 into 7 becomes what? 35. Okay, so now again the like terms over here are only 7x and 5x. this x square is different term and the 35 is different. One is like is we are having is 7x and 5x. So we will find the sum of it. The 7x plus 5x becomes what? 12x plus 35. Okay, so this is our. Now the question is, can we do the division of the polynomial in the same way as we did in addition, subtraction and the multiplication of the polynomial? How do we manage the terms and the exponents during the division? Okay, so before finding the answer to these questions, let us see why we need to divide the polynomials. Let us see some of before see some of the situations. Okay, suppose if I say a car is traveling a distance of suppose if I say x kilometer. Okay, the car is traveling a distance of x kilometer, and the time taken will be suppose 4 hours. Okay, so what we need to find is the speed. Okay, over here we have to find the speed. So how will you find out now? How will you find? So all of you know about the relationship between the speed, distance and time. So we will use that property. Okay, speed equals to distance upon time. Right? So distance given is what? X kilometer. Okay, and the time over here is 4 hour. So your speed will be what? X by 4 kilometer per hour. Okay, therefore the speed becomes what? X by 4 kilometers per hour. This division is easy because it involves division of the polynomial having one term by a polynomial having one constant. Okay, so let us check out the other situation. So suppose if I say you are given a rectangle. Suppose if I say you are given a triangle, a rectangle in which I say the area of the area is given as suppose 40 x square meter square. Okay, so and the length given to you is suppose 10x. Okay, this is 10, sorry. Okay, so now I want you to find out the breadth. Okay, so now what will be the area of a rectangle? The area of a rectangle is the formula for the area of the rectangle is what? Area equals to length into breadth. All of you know that. Okay, so now we will only substitute the values. So area is given as the rectangle as 40 x square, while that of the length is 10x. 10x, and the value of the breadth we do not know. So in order to find the breadth, we will transpose this 10x, so it becomes what? 40x square by 10x, keeping the breadth as over there only. Now when we solve this part, what will happen? What will the answer you will get will be what? So before doing that, let's solve it in a very simplified way. Okay, so that means if 40 can be written into 10, and x can be written as x into x upon 10x means what? 10 into x, right? So now you can see we can deduct 10 ones are 10, 10 ones are 10, x and x got deducted. So what is remaining now? 4 into x. There is nothing in the denominator. So therefore, what answer you will get? 4 into x, that is 4x equals to breadth, or you can say breadth equals to 4x. Okay, understood? So here quotient and the dividend both are the monomials. Okay, and the remainder is also a monomial. Now we divide a binomial polynomial by a monomial itself. Okay, all of you, I hope all of you understood this part. So let's move further. Let us take other example. So before doing that, let us consider some of the example. Suppose if I take the example, the question is divide the polynomial 18, divide the polynomial 18, just a moment, this is not visible to you, at 18 x square plus 9x. This is a binomial having two terms. Okay, binomial having two terms. One is 18x square is separate and 9x is the separate. Okay, so if you are given the question is divide the polynomial 18x square plus 9x by a monomial 3x. Okay, so how will you do? Now 18x square, 18x square divided by 3x plus 9x upon 3x. We can separate the denominators. Okay, is this okay to all of you? Now next, again what we did in the previous question, it is similar to that. Okay, so let's do it like now. What we can see is when we divide 18x square by 3x, when we divide 18x square by 3x, what will be the answer? You will get the answer is 6x. Okay, so similarly when we divide 9x by 3x, then what will be the answer? It will be 3. The answer will be what? 3. So what the answer you got is 6x plus 3. So now when we say about the mathematical problem, is this just can be used in solving the problems related to your book or textbook only? It is not like that. Okay, the process of division is followed in the above examples can also be used to solve the practical problems as well, right? Okay, so we will see the examples of that also. Some of the examples suppose if I ask you to divide a line segment AB whose length is suppose 8x units. Okay, and we have to divide it into two equal parts. What I told, I am giving you the line segment AB. Okay, and suppose it is of 8x units. Okay, 8x units, and I am asking you to divide this into two equal parts. Okay, so how will you divide it? What will be the length of each part? Okay, so suppose C is any point, suppose CE is any point in the line segment AB, which divides AB into two equal parts, that is AC and CB. Okay, so we can write the above expression as what? AB equals to AC plus BC. Okay, now since C divides the line segment two equal parts, so what we told, two equal parts, therefore we can say that AC is equals to BC. Okay, so therefore we can write the this equation to be AB equals to AC plus AC. Okay, so now AB, the measurement of AB is what? This 8x, so we will write 8x in place of AB, and in over here in the right hand side, AC plus AC becomes what? Twice of AC. Okay, it becomes twice of AC. Now we transpose this 2 on the other hand. Okay, other hand, so it becomes what? 8x by 2. So that means when we divide this 8x by 2, what will be the result? It will be 4x equals to AC. Okay, that means what we got the value, that is AC equals to 4x. What is the resultant? It is AC equal to, this is the required answer. Okay, hence the length of both the line segments that is divided are of 4x units each. Now till now what we have seen, division of the monomial by monomial, binomial by monomial, and the polynomial by a monomial. Now going further, division of now we will see the division by the polynomial with the multiple terms. Now while dividing multiple terms by a one term polynomial, we first write each term separately. Okay, now let us see how we factorize the polynomial. 18, suppose if I ask 18 x square plus 9x and divided by 3x and divided by 3x. Okay, so in order to do this, what we will do, we will divide first of all, we will factorize it. How will you factorize? So 18x square can be written as 9 into 2, as 9 into 2 is 18, 9 into 2 into x into x. Okay, similarly 9x can be written as 9 into x. Okay, upon 3x is 3 into x. Okay, so what will be the common in this? You can see 9 and the second term also having 9, but there is no 2, but x is there, so therefore what we can take out 9x as common. Okay, we can take out 9x as common, and what will remain inside? 2x plus, okay, whole upon 3x is 3 into x is 3x itself. Okay, so now moving further, when we divide this 9x by, when we divide this 9x by 3x, what we will get? only 3 3s are 9, therefore 3 you will get, and x and this x and x gets deducted. Okay, this x and x gets deducted. Okay, so therefore what is remaining now? 2x plus 1. So there are. Now suppose if you have to divide the polynomial, if I say the polynomial 2 with let's take the polynomial 2 with 2x square plus 5x minus 3. Okay, 5x minus 3 by x by 2. So can we apply the above method of the division in for solving this? What we can see over here, but we cannot find any common factor. Okay, over here we cannot find any common factor in numerator and the denominator. Okay, and we cannot determine the quotient. In this situation we can use the long division method of division. Okay, so in the algebra you know that the meaning of division. Suppose if I want to divide 25 by 4. Okay, this 25 over here, 25 is called dividend, 4 is called divisor. Okay, when I go to divide, so we can say that 4 6 are 24. So what will the answer you get? What is remaining? This 1. This r over here is called the remainder. This is called the quotient. The number that we are dividing, it is called the dividend, and by the number by which we are dividing is called the divisor. Okay, so when we see the relationship between this, so what is the relationship we have? That is divisor, so dividend equals to divisor into quotient plus remainder. Yes, all of you know that. Now over here the divisor is what? Dividend is what? 25. So let's write over there. Okay, and divisor is what? Divisor is what? 4, and the quotient is 6, and the remainder is 1. And so when we go to solve this, we will check that if this is true or not. So 6 are 24 plus 1. So 25 equals to 24 plus 1 is 25. That means LHS becomes equals to RHS. So we can say that this relation that we are getting over here is the relationship between the dividend, divisor, quotient and the remainder. Okay, so that means if we do not know the dividend and we are given divisor, quotient and the remainder, we can find out the dividend. That means in this equation, if any of the three values are given to you, then you can find out the fourth value also using this relationship. Okay, so moving further to the other topic, you will see now the long division method. Okay, now let's divide this expression over here, okay, that we have taken with the long division method. Okay, so now let me drop this first. Now let's divide this expression with the long division method, since because we were unable to divide, we were unable to find any common factor in this, so we will use the long division method. So as in the simple traditional method, we will use the divide the since x minus 2 is the divisor, we will write x minus 2, okay, and the dividend is 2x square plus 5x minus 3. Okay, so now in order to divide, now there are the sum of the rules in order for the division. Okay, so what the first step says, we will write the steps as well in this. So what the first step is of division is, in order to divide we will write the simple steps first. Okay, this step says write the dividend and the divisor to be in the decreasing order, in the descending order of degrees. So the first, remember this always, if over here the degrees are already in the arranged way, that is in the descending order, so we not have to rearrange writing in the descending order. But whenever if the degrees is given in the unarranged way, in an so we are required to arrange them first. Okay, so step 2, what the step 2 says, divide the first term. Remember always what does it say, divide the first term of the dividend by the first term of the divisor. Understood? Divide the first term of the dividend by the first term of the divisor. Over here the first term of the dividend is what is the first term of the dividend? That is 2x square. Okay, and the first term of the divisor is x. So let's divide it. What you will get, 2x square divided by x. Okay, what will be the answer? That is, when you are dividing it, when we factorize it becomes 2 into x into x upon x. So this x and this x gets deducted, so what will be the answer? 2 through x. Okay, so write this 2x over here. Okay, 2x. Understood? That will be the quotient. Okay, this is the first term of the quotient. So 2x square upon, similarly when you have to multiply minus 2x, this minus 2 into 2x, the answer will be minus 4x. Okay, so we will change the sign, so the sign you will be plus and the minus over here, right? Deduct 2x square minus 2x square, deduct it, what will be the answer you will getting? 5x plus 4x is 9x, and this minus 3 will also come down. Okay, now moving on to the step number 3. So we will repeat this process till the remainder becomes 0 or the degree of the remainder becomes less than the power of the variable of the divisor. Okay, that in this the remainder is 15 in this example, and its power is less than the power of the variable in x minus 2. So when we go to represent this division, it becomes what? 2. It becomes, how will you represent it? 2 x square plus 5x minus 3 equals to, this is the dividend, equals to divisor, that is x minus 2 into quotient, that is 2x plus 9. Okay, and the remainder is what? Plus 15. Okay, so therefore you can see what we have written is this is called the dividend. Okay, I will write in this one, dividend. This one, this 2x plus 2x square plus 5 is the dividend, and equals to x minus 2 is the, what is x minus 2? X minus 2 is the divisor. So you can write divisor into quotient. Okay, 2x plus 9 is what? It is the quotient, that is cube, and 15 you got is the remainder. So this is the representation of this division. Similarly, you can practice several number of other examples.